Now I introduce a linear quadratic regulator. For a general nonlinear dynamic system, it's very hard to find a policy or a sequence of controls that can generate the optimal trajectory for a system move from initial state to terminal state. However, if a nonlinear system have a locally linear dynamic, so the system is a dynamic is a nonlinear. However, the local dynamic is a linear. And the cost function is a special quadratic. The linear quadratic regulator can be applied to solve for that a sequence of controls for the optimal trajectory. Assume the local dynamic is a linear in this formulation. X is a state, U is a control. Matrix A and B to balance the contribution from the control and the state. Linear quadratic regulator requires specific quadratic cost function along the trajectory. Let's define a cost function in this formulation. First term is for the terminal state, and the rest of them is along the trajectory. The goal of a linear quadratic regulator is to find the control sequence to obtain the optimal trajectory. Linear quadratic regulator minimizes the cost function with respect to control, subject to control constant linear dynamic. The goal is to find the control sequence. Here, the F is usually the F is a coefficient matrix, and this dynamic will generate the optimal trajectory. Here, F in this formulation. So to calculate the F from F and state, decide or select this control, we need to calculate the P. To calculate P, we combine this dynamic into the cost function, and then we calculate derivative of the cost function set to 0 and solve the Riccati equation for this P. So we got this backward P update from terminal to initial state. So in the backward path, we step by step calculate the P. And then in the forward, from the P, we calculate in the last step, we calculate the F from initial state to terminal state. Once we got this F for a given state X, we can decide what's the action we should take on to run the system. That's the method of the linear quadratic regulator. For more details, please check with this reference. Thank you. Bye.